Hello everyone, this is Professor Shilpa Patil. In this video lecture, we are going to study about a sequential circuit. In our earlier lectures, we already studied digital circuits are classified into two types. One is a combinational circuit and another one is a sequential circuit. Right? And we have studied about the combinational circuits also. So the combinational circuit is a circuit whose output depends upon the only on the present input. It doesn't depend upon any past history of the inputs and outputs. Whereas a sequential circuit is a circuit whose output at any instant of time depends upon the present input as well as a past history of the inputs. The example for the sequential circuits are latches, flip-flops, resistors, counters, etc. So these are the examples for the sequential circuits. So the block diagram of sequential circuit is obtained by the block diagram of combinational circuit itself, right? So first what we will do, we'll just draw the block diagram of a combinational circuit where you will give an input and based on your present input you will get an output. That is a block diagram of your combinational circuit. So here your sequential circuit is also depends upon the past history. So I need a memory elements to store the past history. So whatever we have got a output that will be stored in a memory element, right? Then we will fed back to the input of the circuit to get an next state output. Okay, so this is how we will get an block diagram for a sequential circuit. Okay, right? Then based on the operation of a circuit, we will divide a sequential circuit into two types. One is a synchronous sequential circuit and another one is an asynchronous sequential circuit. Okay? In a synchronous sequential circuit, the change in an output occurs only during the occurrence of the clock pulse. Whereas in a asynchronous sequential circuit, the change in an output occurs whenever there is a change in an input. Means it doesn't depend upon any clock pulse. Okay. So we will just compare the synchronous sequential circuit and the asynchronous sequential circuits. Okay. So the first comparison is nothing but a definition of a synchronous and asynchronous circuits itself. Okay. So the change in an output is determined by the clock input. Whereas in a asynchronous, the change in an output changes with a change in an input, irrespective of the clock input. Right? In a synchronous sequential circuit, the flip-flops are clocked flip-flops. Whereas in a asynchronous, those are unclocked flip-flops. Okay? Since a synchronous sequential circuits depends upon the clock input, the operating speed is depends upon the time delay involved. Whereas an asynchronous sequential circuits operating speed is faster since they doesn't depend upon any clock pulse. And the synchronous sequential circuits are difficult to design, whereas asynchronous sequential circuits are easy to design. Okay, so this is what about a synchronous sequential circuit and asynchronous sequential circuit. So we will study one by one in a further lectures. So before going to the actual sequential circuits, that is latches and the flip-flops, so first we will study a basic bistable element. Okay, so basic bistable element. Okay, so this is a basic building block of the latches and the flip-flops. So why we call it as a bistable element? Because it has a two stable states. Okay, so that's why we call this circuit as an bistable element. So this circuit is designed using two cross-coupled inverters, right? So I have taken two inverters here which are cross-coupled. Okay, so A is an input to the first inverter, we will get an output of Q that is fed back to the input of a inverter 2, that is taken as P, and the output of inverter 2 is Q bar. Okay, so when you analyze this circuit, means when you give a input, different inputs, you will get two stable states. One is a logic 0 state and another one is a logic 1 state. Okay, so we will analyze with the different inputs. First, take A as 0, right? When A is equals to 0, so what is Q? Q will be 1. That 1 will be fed back to the inverter 1, that is B is equals to 1. So Q bar is 0, right? When you give an A as 0, you got Q as 1 and Q bar as 0. When Q is 1, we call it as it is in a 1 state or a set state, right? Therefore, this is used to store a bit 1. Similarly, when you take A is equals to 0, sorry, A is equals to 1, then you will get Q is equals to 0. That same will be fed back to inverter 2. So therefore, B is equals to 0. Then your Q bar will be 1, right? So when you give A is equals to 1, your Q is 0. So it is referred as 0 state, or we call it as a reset state. Therefore, this is used to store a bit 0. Okay. So when we give a different inputs to A, so we got two states here, right? One is a 1 state, that is logic 1 state, and another one is a logic 0 state, right? Hence we call it as bistable element. And even you observe here, so when you give A is equals to 0, right, your Q is 1, means it is storing the bit 1. Okay, when you give A is equals to 1, it will store bit 0, right? So hence it will store a 1 bit of digital information. Therefore, we call it as 1 bit memory cell. Okay, and since that information on the circuit is latched, okay, so when I give A is equals to 0, your Q will be 1, that will be again Q bar is 0, then again A is 0, right? It will be feeding back until unless you change A input, that information will be locked in the circuit, right? That's why this circuit is called as a latch. Okay, so this is an basic bistable element, which is a basic building block of all the latches and the flip-flops. Okay, now we will study about latches and the flip-flops. So the latches and the flip-flops are the basic building blocks of the most of the sequential circuits. So where you can store a binary information. Okay, so the main difference between the latches and the flip-flops is in their method used to change their states. Okay, so whenever you give an input, so how they will change their state of output, based on that we will differ the latches and the flip-flops. The flip-flop will change its output only during the occurrence of the clock pulse. Okay, so that is the change of state will be done only during the clocking state, whereas the latches are independent of the clock input. Okay, so there the latches will change their state, okay, only during the enable, active enable. Okay, so in a latches we have an enable as an controlling point, whereas in a flip-flop we have a clock pulse as a controlling point, means changing the state. Okay, so we have different latches and the flip-flops. In that, first we will study a SR latch. Okay, so SR latch using NOR gate. So why we call this as SR latch means, so it has, when you analyze the SR latch with the different inputs, you will get two states, set state and the reset state. That's why we call it as a set reset latch, SR latch. Okay. So first we will design an SR latch using two cross coupled NOR gates. Okay. So this is how as the circuit is designed for an SR latch using NOR gates. So two NOR gates are cross coupled. Okay. So it has two inputs S and R and two outputs Q and Q bar, which are complementary each other. So it is same as your basic bistable element. Here we have designed using the NOR gates. Okay. So now we will analyze this latch for the different inputs of S and R. Okay. So I'll just redraw this latch again so that we can analyze the output for the different inputs. So we have two in NOR gates. So one and NOR gate 2. Okay. So for one I'll connect the input R and for another I'll connect the input S. Those two are cross coupled. Okay. So we'll get an output of Q and Q bar. Okay. So now we will analyze with the different inputs. Now I will give an input R is equals to 0 and S is equals to 0. When R is equals to 0, S is equals to 0, we cannot get an output of Q and Q bar. So I have to assume the previous state. Okay, so since we don't know the previous state, we have to assume the previous state. So first I will assume the previous state Q as 0 and Q bar as 1. So if you assume Q as 0 and Q bar as 1, so the another input to the NOR gate 2 is 0. Right? So the another input to the NOR gate 1 is 1. Okay. So when the input to the NOR gate 1 is 0, 1, the output will be what? 0. And similarly, the output for the second NOR gate, we got it as 1. Okay. So when you assume the previous state as 0, 1, then you got a next state as 0 and 1. Okay. So similarly, we will just assume. Okay. We have assumed Q as 0 and Q bar as 1. We will assume Q as 1 and Q bar as 0 now. Okay, I'll just change it now. Okay, so now I will assume Q as 1 and Q bar as 0, right? So then the input to the second NOR gate is 1. So another input to the first OR gate is NOR gate is 0. So I will get my output as 1 here and I'll get my output here as 0. Okay, so when you assume Q as 1 and Q bar as 0, you got Q as 1 and Q bar as 0. Right? Just observe it. So whatever you have assumed, you got the same thing. Means whatever you have assumed the previous state, you got the same next state. Okay, that's why we will declare it. So when the S is equals to R is equals to 0 in an SR latch, the latch will remains in its previous state. Okay, so similarly we will analyze for the different inputs, right? So this is what just now we have discussed. When S is equals to R is equals to 0, you have to assume the previous state. So when you have assumed the previous state, you got the same state, right? So that's why we will write it and it is in a previous state. Okay, similarly assume the different inputs. Okay, so case 2 I will take when S is equals to 0 and R is equals to 1. If you analyze the circuit, right? So when S is equals to 0, R is equals to 1, without any second input, the NOR gate 1, upper NOR gate, the output will be what? 0. So the Q will be 0, right? Which in turn fed back to the second NOR gate. So the input to the second NOR gate is what? 1 and 1. So your Q bar will be 1. Okay. So when S is 0, R is 1, you will get Q as 0 and Q bar as 1. So we call this as a reset state. Similarly, analyze by taking S is equals to 1, R is equals to 0. you will get Q as 1 and Q bar as 0, right? Hence we call it as a set state. Okay. So when you analyze, S is equals to 1, R is equals to 1, right? So when both the inputs are 1, 1, so we will get both the outputs of the NOR gates as 0. Okay. So hence when S is equals to 1, R is equals to 1, your Q is equals to and Q bar is equals to 0, right? Which is against to the universal law. So always the output should be an complementary, Q and Q bar. Okay. So hence when S is equals to 1, R is equals to 1, in an SR latch, it is an forbidden state. Okay, right? So based on these input uh, and output, so we will frame the truth table. Okay, so we have taken the different inputs. First I took S is equals to 0, R is equals to 0. So whatever I assumed the previous state, I got the same thing. Okay, so I have written previous state Qn and Qn bar. Means there is no change. Either you can write it as a previous state or you can write it as no change in the output. Right? Then when S is 0, R is 1, we got Q as 0 and Q bar as 1. Right? This is an reset state. When you take S as 1 and R as 0, you got Q as 1 and Q bar as 0. So that is an set state. So when both the inputs are 1, 1, so we got both the inputs as 0, 0, right? Which is a forbidden state. That's why we will write it as an don't care. Okay. So here, just see the truth table. How many states we have? We got set state and the reset state, right? Hence we call this latch as an set reset latch. Okay, right? So again here, so in the last state when S is equals to R is equals to 1, 1, that is a forbidden state. Okay, so in order to avoid that forbidden state, this SR latch is altered as a JK latch, where it will overcome this forbidden state. Okay, so we will study the different latches in the next lecture, like D latch, JK latch, and T latch. Okay, thank you everyone.